Introduction to vectors. Here is a question for you regarding opposite vectors. For each of the following vectors, describe the opposite vector. So I would like you to read these 4 questions and answer them. After that, look into my suggestion. A. A car traveling due south at 80 kilometers per hour. B. A person walking due northeast at 5 meters per minute. C. Bird dives at 90 kilometers per hour at the bearing of 170 degrees. D. An airplane flies south 30 degrees west at 400 kilometers per hour. So answer these questions and then look into my suggestions. So we have done a couple of videos on opposite vectors, and you understand opposite vector has same magnitude but opposite direction. That's it. So we will just maintain the magnitudes, that is these figures, right, for each one of them, and reverse the direction, right, for each one of them. We'll reverse. This is the direction, that's the magnitude. So that's what we are going to do now. And here is how we can do it. So as a reference, I'll make my coordinate plane and just write east, west, north, south on this, right? So this is east, that is west, and we have north and south, correct? Now north is positive direction for us, east is also positive direction for us, south and west are considered negative directions. The first one is car traveling due south. That means in this direction, right? So opposite to south is north. So that's what we get, right? As you know, magnitude is same. So we'll keep this as 80 kilometers per hour and change this direction from south to north. So that becomes our answer. Say car traveling due north. So replace these words at 80 kilometers per hour. So we get the first one in this way, correct? Now for the second one, a person walking due northeast at 5 meters per minute. So northeast is this direction. So we'll reverse this direction to this, correct? Maintain magnitude, that means 5 meters per minute, and change northeast to south west, reverse, right? So we get south west. So that is the answer. Perfect. Next one, bird dives at 90 kilometers per hour at the bearing of 170 degrees. Now bearing angles are measured from north and rotation is clockwise. So 170 from here will be like very close to this line, right? So let's draw this line kind of like this. Is it okay? Kind of like this. So this angle, let's assume this to be 170. So that's 170 degrees. Now what is opposite of this? That one, correct? So in bearing angles, what you can do is you can add 180 degrees always to get your answer. So that is how apart they are. Do you see that? So that is adding 180, one full line. So that can help you to get the right answer. That's one way to do it. The other way is that you know this angle is 10, this is 70, that means this is 10. So this is 10 left, right? So it is 10 less than 360. So that way you get this angle as 350 degrees, right? So both ways you can check. When you add 180, you get 350 degrees, right? So that's how you get your result here. And magnitude has to be same. So it's 90 kilometers per hour at a bearing of 350 degrees. Do you see that? So that's how you get this answer. Now, let's try to get the answer for the last one, which is south 30 degrees west, right? So from west it is 30 degrees south. That means kind of like this, right? Let us say this is 30 degrees. That's what it means. So you move south 30 degrees from west, right? So opposite for this is this direction. Is it okay? So this is vertically opposite angle, 30 degrees. So what has happened? You're moving actually north from east. Do you see that? So you have to just reverse these. So south becomes north, 30 degrees remains same, and west becomes east. That reverses the whole direction at 400 kilometers per hour. So opposite vectors are easy to get, and that's how we get them, correct? So I hope you understand and appreciate. So let's move on to the next topic. Thanks and all the best.